Okay, I thought I'd do an example from integral calculus, calculus 2, and this problem I came across. I thought it was pretty interesting because it's a little difficult and it really gets into those trig identities and integration by substitution of trigonometric identities. And it doesn't look hard, when you look at it, but this is really a pretty nasty problem. Okay, uh, so we're going to try to solve it, and hopefully we can get through it. One thing you should notice here is that's a little difficult to see. We have to get rid of this x dx, okay? And the way to do that is with the substitution, okay? And if I let u equal x squared, okay, the derivative of u is 2x dx. So here's our x dx we can substitute out. This means that du divided by 2 is equal to x dx. So now I can rewrite this integral, and this problem's probably going to take about 3 pages to do, maybe. I hope not, but as 1 half. Okay, so there's our 1 half out of there. Okay, x dx is going to become du, and u is x squared, so that means we're going to have the square root of 1 minus u squared. Okay, and x dx is going to finish off here with du. Okay, so we got that substituted out there. Now that's probably the hardest part of the problem, is recognizing that little identity there, other than some things with back substitution. Okay, so what do we see here? We see a 1 minus u squared in the radical. That should mean that we're going to let u equal sine theta. Okay, and why do we let u equal sine theta? Well, that's because if I substitute u equals sine theta, we're going to need a du. Du is cos theta. This is going to make, I'm going to pull the 1 half constant out, that this integral is now going to be 1 minus sine squared theta, and du is now cos theta d theta. Okay, so it's going to look like this. And that's our regular substitution that we're going to learn in calculus 2. And why do we do that? Well, because we know that 1 minus sine squared theta is happily cosine squared theta. So now we're going to have cosine squared theta. And this is because sine squared theta plus cosine squared theta is equal to 1. Okay, so if I solve for sine squared, 1 minus sine squared theta is going to give me cosine squared theta, which isn't there. And I still have this cosine theta d theta on the outside. Okay, so the square root of cosine squared is cosine. So this cosine times cosine is going to make this 1 half times the integral of the cosine squared theta d theta. Now to finish this out, we're going to have to go to wonderful trig identities that we learned in trigonometry that everybody forgets, and I even still have to look them up, but to integrate this is going to actually be the integral of cosine squared theta is 1 half times 1 minus, actually it's plus sine 2 theta. Sine 2 theta? Cosine 2 theta. Cosine 2 theta. And I just wrote that terribly. That's okay, because I'm going to rewrite it again when I multiply this 1 half out here. So it's going to be 1/4 times the integral of 1 plus cosine 2 theta. Okay. Alright. And this part's pretty easy, because this is going to be 1/4 times theta, right? Because the integral of 1 is theta. Plus the integral of cosine is positive 1 half sine 2 theta. Okay, now plus a constant since we integrated. Now that so far is the easy part. The hard part, now we have the integral, right? Everybody thinks, yeah, that's the answer, but the original problem was an x, so we have to back substitute back to x. Okay, and I'm going to try to do some of the substitution up here so that we have some room. Okay, so one thing that we need to do is use this identity here. Okay, so this is going to be a triangle. Okay, and here's our theta. Okay, and sine is opposite over hypotenuse. Okay, so that we're going to have a opposite is going to be u, because this fraction can be written as u over 1. Okay, and then the adjacent here is going to be the square root of 1 minus u squared. Okay, square root of 1 minus u squared. Now, the hard part is I don't have sine 2 theta. I don't have sine theta. I have sine 2 theta. So we have to use one of those crazy identities. So this is going to be 1/4 times theta plus, to make it, we're going to have to use the fact that sine 2 theta is equal to 2 sine theta cos theta. Okay, so now everything's in theta, which is good. I mean, I know the sine, I put the sine theta, I mean, from this triangle I can also find cosine theta, so that's great. So that really helps us out. So this is going to be times 2 sine theta cosine theta plus a constant. Okay, so I'm going to, hopefully I'll try not to lose too much here. Okay, well, theta, what's theta? Well, if sine theta, right, is u, that means that theta is inverse sine u. Okay, so this is going to be 1/4 times the inverse sine of u. Okay, plus, now this 2 and this 1/2 are going to cancel out. That's great. Sine theta, okay, sine theta is u, and cosine theta is the square root of 1 minus u squared. Where does that come from? Well, if this is theta, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so that's where that goes. Now, all fun and games, that we're not done yet, because this is in u and we still need to go back to x, so we need to use this identity here, and that's just a simple make u x squared. Okay, so that's not too bad. So the final little guy here, the final little substitute, we can go ahead and write that the integral of x times this 1 minus x to the 4th is 1/4, okay, 1/4 times the inverse sine of x squared plus u is x squared times the square root of 1 minus, well, if x squared squared is x to the 4th plus a constant. And that's a really nasty guy, huh? That's probably about as hard as you're going to get in trig sub. Maybe. Here's your final answer.